Hey everyone, so this is the second part of our coffee shop case study, and the fifth question says that take employees with overlapping shifts, same date or overlapping times. So we will identify shifts where more than one employee is scheduled to work at the same time, right? This is useful for workload planning, avoiding crowding or coordinating teamwork. We'll work through the query step by step and explain a new function called a string aggregator, which help us combine employee names into a single line. So let's begin. First, let's understand which tables we are going to use in this query. So this is the staff table, right? It has all the information about staff, right? And the second table is shift. It has all the information about each shift and its time, like start time, end time. And the third table is coffee shop. It has all the records of which staff worked when, right? Like shift id, staff id, date, etc. So let's start writing the query. First we are starting with a common table expression, and we name it overlapping shifts to extract overlapping shifts. It's a temporary table, right? With overlapping shifts as now we are selecting shift id and date from coffee shop table, coffee shop the date, and start time and end time from shift, right? Start time and end time, shift at end time. Now we are using string aggregate function to combine all the employee names assigned to this shift. In the first parameter, string aggregator, and the first parameter we have to pass the expression, and in second the separator, right? So in first parameter we have to pass the names for concatenation. Okay, so start at first name and its last name. We'll use the concatenation operator used in Postgres SQL or some other SQL databases. And this is the space, and now we'll give the last name, right? Now in the second parameter we will use this operator to separate employee names who is working together. And let's name it as employees because it's showing the employees that are working together on the same shift, right? As employees. Lastly, we will count how many employees are working in the same shift using count function. We are using count star because it counts all the rows in the same result set regardless of null values, making it safe and reliable for counting total records like employees on a shift. Let's name it employee count from coffee shop table, and we'll use alias cs. After that we will use inner join to connect the three tables only where matching data exists. These give us a list of employees and their shift at the coffee shop and leaves out any incomplete or mismatched records. So this is the shift table. We will connect it with shift id. Now join shift as alias on coffee shop. The shift id should be equal to shift id, and now again we will join coffee shop table with staff table, staff st on coffee shop dot staff id should be equal to staff dot staff id. Inner join will give us only the rows where matching data exists, right? Well, now we will group the data by each shift time, so we can count how many employees work together in that time slot, right? Also, if you are using aggregate function, you must use a group by clause, otherwise you will get an error. So group by ch.shift id, cs is the alias of coffee shop, right? Coffee shop.date, staff.start time and staff.end time. Okay, so let's run the query to see what it returns. Okay, there is a mistake. I forgot about the concatenation operator, right? Between the first name and the last name. So I have to add it. Let's run it again. So in the output you see the shift and its start time and time and employees that are working on that shift. Also its count, right? Now we'll use a condition to filter the data where two or greater than two employees are working on the same shift. I have this condition and it depends on every business, right? You can set it based on your own business rules. For me, if two or greater than two employees are working on the same shift, then it's overlapping shift. You can set the condition, right, based on your own business rules. Having count star greater than one. Where we are using having instead of where, because where filter rows before grouping and having filters groups after grouping, right? Also you cannot use aggregate functions in where clause, so you have to use it in having clause. So this will filter only the rows where two or more than two employees are working on the same shift. So let's run the query to see the output. Now it filters all the shifts where employees are two or greater than two. You can so the query is complete, right? But why did I use city? Because you can set a condition on employee count, right, outside the city, and also do many other things like rank or others. So that's why finally we'll select the full result from our temporary table and order it by date and shift id, so it's easy to read. Employees count from overlapping shifts, order by date and shift id. Well, let's run the query. Okay, so the error is we forgot the s employees count. Let's run the query again, and as you can see on the screen, the output shows employees greater than one. We don't have shifts with employees greater than three, right? So that's why it's only showing two. Now I change the condition to greater than two, and you can see it shows nothing, right? So it means there is no shifts with employees greater than two. Now this is the sixth question of our coffee shop case study, and it says identify shifts with insufficient staff, right? Now the condition I used here is based on my own business logic. I have defined a shift as insufficiently staffed if one or fewer employees are assigned to it. That means if there is either only one person or no one at all on that shift, I want to flag it, right? This is just one example. You can definitely customize this condition based on your own business rules. For example, in a bigger coffee shop, you might consider anything below three staff members as insufficient. So again, this part is flexible. The key is you define what insufficient means for you and for your business logic. Now for the logic itself, we'll be using the same structure we built earlier in the overlapping shifts query, right? It's the previous query, and the only thing that really changes here is the condition inside the having clause, where we write having count star is less than equal to 1 to isolate those understaffed shifts. I hope you understand that. Okay, so now we'll copy the part of the previous query where overlapping shifts is extracted from coffee shop shift and staff tables. And here we will only change the condition, right? Let me run this query to see what it returns. And the query returns, you can see the employees greater than one, right? We will only filter shifts where employees are less than or equal to one. So let's modify the condition. Having count of employees is less than equal to one, then there would be shifts with insufficient staff, right? Let's run the query now. Now on the screen, you can see on the output, it only returns the shifts with employees count is less than or equal to 1. So we don't have any shifts with employees is less than 1, right? That's why it doesn't return it.